Hi, and welcome to a tutorial about how to create hard-edged panels in ZBrush. Now yes, ZBrush does have the panel loops tool, but that tends to give some softer edged results in some circumstances. So looking here at our render that's created in ZBrush, you can see we've got multiple panels on a curved surface with some rather sharp edges going about. Now some of these are actually quite hard to create in any other way than what we're going to look at in this particular video. So you can see we've got some really nice, sharp, clean geometry, with very clean planes, which obviously you wouldn't be able to get through sort of hand polishing and other methods. So we're going to be looking at pretty much topological modelling within ZBrush to achieve these sharp edges. If you want to jump ahead to the solution and how it's done, you can jump through to the time frame showing now. But otherwise we're going to look at some of the issues that are raised and why we've done this method and some of the other methods that are available. So here you can see an object that's created. It's the same object, but this one has had a more traditional panel loops method. So maybe we've created edge loops first, and then created panels from there. And as you can see with the polish modifier, it's ended up smoothing it out. And while this is nice, maybe for a car design or something like that, you can see once you start pushing these bevels past a certain amount, they actually start to little cross back on themselves. And you can see above this panel here that there are issues where the geometry is self-intersecting. The method we're going to look at shortly will actually help and allow you to see this rather than stop it. So we'll start off looking at what panel loops do by default. So I'm just going to slice our object up using the slice curve into different polygons, and as you can see, it's given us very clean edges, but very, very bad topology. And something that if we were to use inset or bevel edge, it will go horribly, horribly wrong. So let's take a look at what we do with panel loops. Now panel loops at the moment, this one's got a bit of a polish on there, and it smooths it out, and it does a reasonable job, but it's not what we're after. This is looking almost like a leather-stitched basketball. It's certainly not the smooth, hard panel lines that we are looking for. So maybe we can look at how it works if we polish out a bit more. Maybe it will get rid of some of this beveling, but as you can see, it's just making the shape lose its integrity. So instead, let's clear polish, and now you can see keeps the hard edges, but because it's not polishing some of this geometry, you can see we've got some horrible meshes, and just smoothing out there you can see where the problems lie. So polish by groups beforehand. Perhaps we could polish by groups, and then use the poly loops to do it with the polish turned off. And this is indeed a method they use quite a lot, where you actually polish the groups, and then you have much more control over it, and then apply the panel loops. And again, you can see this has given us much better geometry on the edge of the model, but it's still not the result that we're looking for when we look at the original model. So how else can we clean up the topology? Well, we can try ZBrush. So if we keep groups and remesh, boom. It's not done a bad job, but you can see there are problems here, and that's just not going to give us the poly loops we want. And it's curving off down here. It's just really not gone for it. We can try poly by groups again, smooth that out. But again, you can see it flattening out the areas. and we'll put a panel loop on that just so we can see where the result would go. We'll go edge loops, panel loops, and you can see this is the positive of some errors, giving us harder meshes, but still nothing like what we want, nothing like the goal object. So what we're going to need to do is start with good topology. So what effect does topology have on panel loops, or indeed bevel and any other method we want to do to get our panels? So let's start again. Let's look at a cube. So here we have a basic standard cube, and we'll use the ZBrush brush to investigate it. So you can see the edges here are running 90 degrees to the top surface. So if I select this edge and press spacebar, we get some options, one of which is bevel. And then you'll see down here we get some further options on the type of bevel we can apply. So a standard straight bevel is scalable, but it only goes to halfway along any particular face. So that's the maximum that the bevel will travel. It will go no further. Now here you'll see we've applied a bevel, and it's a longer face on the sloping side. So now it will stop on the top face and continue further on the side faces. So the length of the faces has an effect on what you can do with the bevel. You simply cannot go any further than halfway along a face. The other thing that will have an effect on the purity, if you like, of the bevel is how many edges go into a vertex at the side of the border of where you want the bevel. So here now, I've split a face and made it so that two edges are going into a single vertex. So now, if we select the bevel and apply it, it goes horribly, horribly wrong. And this is what was happening before when we looked at the edge loops, poly loops on the other model. So this is not ideal. You can fix it up. You know, we can go in there with the move tool and address the issues. So we can go in, review, grab the vertices and move them and fix it to mesh right up. But you can imagine when we start getting into complex meshes, this is going to be very time consuming and inaccurate and give us a rather ugly effect. So to achieve best results on our bevel, it's important that we get the edges coming as perpendicular as we can to the border of the edge we want to bevel, and also only have one edge going into each vertex. Now when we start to subdivide, you can see this starts to blend the shape and make a curve. Now if we want to control this a little bit and have some hard edges, we can go with the creasing tool, and we can crease by polygroup, and you'll see that will then give this crease, but it's actually missed the edges and given it a strange smooth effect because it's only creasing the borders of the polygroup. And this lime green polygroup you see doesn't have an edge, and it gives us sort of a kind of posh jam jar. So we actually need to go in and somehow crease these corners to give us a stronger edge hold. Now we can do this with the ZBrush brush. There is a option for crease, and you go in and click each edge or edge loop, same as a lot of other polygroup tools. However, we can also set the tolerance for crease, and basically you set the angle level, and any angle greater than the number you set will then be creased. So if you set it to 45 degrees, any angle that's greater than 45 degrees will have a crease applied to it. And then you see I've basically subdivided twice with the crease on, and then I've turned off all the creases, cleared them all, and then subdivide it further. Just soften off the edge a little bit, give us a nice moulded feel to the object. So what other control do we need over our bevel? We've talked about the fact that the actual size of the faces either side of the bevel have an effect on how far you can go. So when your mesh is big polygons, you can go a large amount. If I divide this up, I've got a much tighter set of polygons now, and you'll see as I try and select these edges, how far we can go is limited, and we just simply cannot go any further and make our bevel larger. So if we want large bevels, we're going to have large loose topology. If we have tighter topology, we will have tighter bevels. So that gives us control over the size. There's also control with the bevel tools in ZModeler to allow you to inbuild how tight the curves are. So first of all, you can see we can actually add 2 rows, and you can see now that there is an extra poly loop in there, or edge loop. And we can set this up to as high as 8. It doesn't go any further than that. It's not really necessary. Now, the moment if we go to sharp, it will put those edges, it will bias them towards the edges of the loop. This, when subdivided, this moves on, when subdivided, will tighten it up at the top and bottom of the bevel. We undo that and go in now with the soft edge. Do the same again. You'll now see it puts the majority of the curves in the centre and leaves the top and bottom loose. This will give you a more balloon-like, smooth edge to the bevel. So if we go to this setting here, which is a slider, this allows us complete flexibility in how much and how soft we want the corner to be. Now there is a bit of a bug with this. I don't think it's actually going to show up here, but sometimes it will actually add some small triangles to your mesh. No, it's not doing it here. But bear in mind that, I don't know whether it's a bug or a necessity because of the calculations it does, it can cause problems. In this instance though, we will just stick to the single edge for what we're looking at because of the hardness of the type of model. Now the alternative way, we just looked at selecting the edges. But you can actually use the curve functions with the ZModeler brush, and I don't think this is overly advertised. So by selecting just a set of faces and going frame on the border, when you hover over a curve you get another set of options. Mostly useless, but it has the bevel with the same controls as what you have with the edges. So why would you use this? When would you use this over and above the poly loop in the ZModeler brush? Basically, when you've got an edge flow that's awkward and doesn't quite fit and won't be selected easily by a edge loop. But bear in mind it's there. It doesn't provide any extra functionality. It just provides you with flexibility on how you select your edges. The other method, the third method of beveling, is to hide the face and then crease it. And now, with just those edges creased, we have again here a slider which we can adjust the bevel with. So there's 3 different ways. And this has a resolution slider also along with it. And this basically adds the extra loops just like we saw in the ZModeler brush. The only difference here is it only does it the same as the ZModeler brush's hard setting. There's no functionality within this to do the soft or the variable setting. But the functionality is there, and basically it just means that wherever you are in ZBrush, whatever you're doing, you can use whichever one is the closest option for you. So now we've looked at the bevel options, let's look again at the panel loops to see what the limitations are and when it is exactly that we would need to use the bevel instead of panel loops. So I'm just going to take my cube and slice it up using the slicing tool, the ZBrush, and create some nice hard-edged topology. And I'll probably just, I'll pull this back as well on the other edges, just so that it's not causing huge ones to go through the entire mesh. I'll just divide this up. There we go. That gives us a nice selection of meshes. So if we look basically at putting in some panel loops on this, so edge loop, panel loops, you can see there are issues. So if we zoom in again, you can see lots of knotty problems with self-intersections. Now part of this, again, just as with the bevel, there are issues with the size of the topology and how big a bevel you can actually do. So, if we just hide some topology and do these on their own, you will see it pulls them off, and we can just do certain polygroups at a time. Now if I bring the polish up and then turn it on, that looks a lot better. The polish has sorted out some of this horrible intersecting meshes, and because it's really clean topology, it's fixed it up. But you can see there's this weighting problem, there's curves, there's tension and continuity and bias issues, which is causing it to sort of look like it's being stretched and pulled, almost like cloth, into the corners. It's not giving us the straight edges that you would expect from a hard metal object. Also, when we polish, the same as we did before, you can see now, because of this weighting issue, without the other polygroups around it, the corners are collapsing in with the polish selected. So it's not always logical. Well, it is logical, but you need to understand what's happening to find out when groups are going to be a square and when they will actually get rounded out. So in this instance, if we just want a single one to give us the option, we need to use our method where we extrude it using the ZBrush brush, selecting the edge, and using the bevel. We could turn off the polish, but you saw the problems there with the intersecting mesh. So this is when we would resort to using this method for bevels. So what is this method? Well, basically it's taking the object and making nice clean topology and then using our bevel approach. So we'll start again, creating a sphere and slicing it up into the format that we saw before. And what we need to do is look at taking the groups that we get and turning them into neat edged topology where the edges are perpendicular, like we looked at the cube earlier, and that there is only a single edge going into each vertex at the boundary of the surface that we want to bevel. So that's quite a lot to ask, really, from ZBrush, because it's not a modelling program like Max, and this is where you would get certain people reaching for the insert Z-sphere and start topologizing using the old method of drawing on the surface, which is still a valid method, but it's slow. So let's look at just one-click solution of Z remeshing. And we looked at this earlier, and we saw that it was less than ideal. We can turn off the smoothing of the groups. Now this at low polygon tends to cause problems. The actual edges are about right. But what it's done is it's lost the groupings. Maybe if we set it to something in the middle, it will keep the groupings, but then you see we lose the edges. So at the moment, as it currently stands with the code in ZBrush, there isn't a do my work button where we can just click it. We can try freezing the border edges, and it does a nice job there, but as you can see, the topology is again pretty awful. And because of the closeness and number of polygons in a certain area, there's no range to allow us to have a proper bevel. So we're going to have to do it not manually, there's a quicker way. So what we're going to do is we're going to unweld the group borders. So now each of these groups has actually been split up and the edges have been unwelded. So what we can do is split this now, go into subtools and split, and we can split to parts. Click OK, and now we have a whole range of components. So let's look at this big hemisphere here, and you can see it's a nice neat edge, no horrible corners, and so we can just go straight away, inflate, select the edge, and as you can see, problems. And this is because we've broken the rule of the edges being perpendicular to the border, and you can see they're not evenly spaced, and this causes the problem. So we need to retopologize this. So let's just solo this out, and we will go to ZBrush. We don't need to worry about keep groups or anything like that anymore. ZBrush, boom, straight away, just really nice topology. We want bigger topology because we want to have the option to have a large bevel. So I'm just going to click half a couple of times, and we get pretty much perfect topology. And that is just so simple. Extrude it out, go in, select the edge, apply the bevel to the size we want, and you can see from there that it's very, very neat. Let's crease the polygroups, solo that out so we can see it, and you can see where the creases have been placed, subdivided a few times, and that's pretty much perfect. Uncrease the edges, one more subdivision, and that just gives it a nice sort of moulded look. This is exactly what we want. This is exactly what we're going for. So that's easy. One click auto solution. Perfect job. Right? Were it that simple? Let's look at a more awkward shape. Triangle. So this has got lots of sharp points on it. And this is where ZBrush starts to run into some problems. But because we've divided this down into separate objects, they are not insurmountable problems. So again, we'll just do a straightforward ZBrush on this. And again, it's okay. And let's do the half, because the project's way too big. We've lost the pointy corner. Let's keep going. Let's worry about that in a minute. Keep going, keep going. Now it starts to change the topology, where you can see the edges are all perpendicular to the edge, and we've got quads in the corners. But it's lost the original shape. So let's go back to it and undo all that, and we'll take to the subgroup and we'll make a duplicate. And working on the duplicate, what I'll do with this first one, I'll just select it and move it out a little bit so we can see it separate to its brother. And then we'll go back and do the Z remeshing once more. So again, let's turn off that set of value, Z remesh, and then we'll use this half and just keep going. The moment it does a grid, but it will start to change about now to where it's got really nice topology. But, as we say, it's not following the shape anymore. These quads in the corners are really important for when we want to be able to get the bevels going exactly as we want them. But all I'm going to do is just picking a view and making this match up and follow the shape. Now obviously we're moving it in one plane, and you can see it won't follow the shape anymore, but we can project. We can either use the projection from the subtools, or we can use the ZBrush brush. So if we set the shell far enough and select project all, a pretty good job. You can see it's not quite big enough here, and that's because it's actually outside of the boundary. So if I switch to the ZBrush brush and line up my viewpoint so that they're lined up, and then click, and just drag out around the other areas just to make sure it's all neatened up. And now that follows the exact positioning of the original, but with the new topology. So here's my new topology. There's the old horrible topology. So we'll get rid of that. Let's delete the old one. And here you see we have the new lovely topology. And once again, all we need to do here is switch back to Z Modeler brush, and then we can extrude or Q-mesh this out, select the edge, and apply our bevel. And then, by using the tricks we've looked at before, with the creasing, we can go in and we can select geometry, creasing, crease polygroups, and then subdivide. Oh no, we've lost our corners. This is what we have with the panel groups. So we can go in and we can crease these by hand using the tool on the edge in ZModeler. And that will give us the sharp edge. But if you've got a lot of corners on your shape, this might be too time consuming or awkward for you to do. So again, we can set the setting here for the tolerance, and you can see setting it low enough, it's made all the corners go sharp. When we subdivide, now let's uncrease everything, one more level of subdivision, and that gives us this beautiful, beautiful bevel. Now, with the rest of the mesh unhidden, you can see how this is starting to follow the curve and work really nicely. So we'll need to do this for the rest of the panels. Now it is a little bit time consuming, but far, far faster and more efficient, and unless you're very skilled, gives you far better topology than the method where you insert a Z-sphere, adapt the topology, export a skin, and then append the skinned mesh, and then delete the original Z-sphere. It's all very messy and a lot to do. So here we followed the same process. We've simply gone in, Z-remeshed it, brought it down to sort of the size we need to get the bevel we want. I made a copy before I started, so I can move in, just simply using the move brush, go in, line it up. I'll switch to the ZBrush brush and just run over that just to make sure it's exactly in the same plane. And again down here, that's a triangle, might have to split that, but I think if I go to the ZModeler brush, it won't be a problem. In actual fact, there is a vertex there, that is a quad. So I'll just pull that out, because we always want quads in the corners. I'll just change here to the move point and drag that down. Turn off solo mode and line that up beautifully. Select ZBrush brush, get it so it lines up in the Z of my viewport, run over it with the brush, and then we know that will line up exactly. So same as before, now turn off the transparency mode, and all we need to do is get rid of the original, not solo, nice topology, everything where we need it. Yeah, sometimes you can smooth it out with a smooth brush, but in this instance I think we'll just leave it. I'm happy with the topology. We'll go in, select the original, solo mode. There's the original topology. Here's our nice new, much better topology for beveling. So here we have all the rest of the panels are done. I've skipped ahead, and you can see I've worked this through on all the other panels. It didn't take long, a few minutes. And what we'll do now is we'll actually merge these down back into a single object. Now bear in mind these are all different topologies and there's no way that the vertices will line up, so we're not going to be welding this back together. But because of the fact that we want this to be panels, it's not an issue anyway. We've got nice topology now, so panel loops will also work. Remember, this isn't a technique to get rid of panel loops, it just depends on what you need to achieve. So you can check out panel loops. Now there we've got the polish on, so we'll turn the polish down, and you can see it makes a pretty good job. It still has the tendency that we saw on the cube earlier, where the faces flare out a bit, where they're pinched at the corners. This is due to the tension and continuity and bias that's in the panel loops. And again, if we make it too big, it has this issue where faces start to crunch up. And the method using the bevel allows us to visually see this as we work. So I've just simply used the Q-mesh now to extrude out the surface. We will go crease polygroups because the extrude will have created a new set of polygroups. And you can see the creasing there. And now by just sliding that bevel up, and you can see on the corners of the triangular parts where it starts to go wrong when it gets too big. You can also see I've set the resolution slider here from previously, so I'll drop that back down to 0 and undo, and then do it once more. And again, notice where it goes wrong in the triangular corners if it gets too big. So we can visually see and set it right. And this topology is looking exactly right. So we'll crease the polygroups, subdivide, and again we can notice it goes wrong on the very sharp pointy bits. So all we need to do is crease those. And we can use the ZBrush brush, or we can use the crease tolerance. You see that's not quite enough still for there. It's on the corner up at the top, but not this one here. So we'll set that up even higher. This time it's captured that corner, and you can see it keeps that edge nice and tight. Quick check around the model, and we can see it's actually pinched over here, because I guess those faces were within that tolerance level. So we'll undo, and like a lot of things in ZBrush, if that part of the mesh is hidden, it doesn't get affected by a modifier. So we'll only select the polygons we want to affect, and again now apply the crease using the tolerance setting, and now it's worked on that panel and left alone the other edges. Again, you can see just here it's missed that corner on that horizontal strip here. So again, you can move in. We can either do it with the ZBrush brush, or we can hide everything except this area and go in and use the crease tolerance. So we'll do that one. Control-Shift-A and hide all. So again, just make sure it's at the part of it. Control-Shift-A to unhide all of that section, apply the tolerance setting. Now let's subdivide, and that's looking pretty good. And now we'll uncrease all. Well, now it's been subdivided. Subdivide another 1 or 2 times. Let's apply a nice chrome material. And we'll just set this up for a little bit of a render. So I hope you found this useful. It's not quite as automatic as the panel loops, but it does give much finer control, and if you're really serious about doing good quality hard surface modeling, you should find this technique very useful. Thanks for watching.